Greetings, folks. So today we're going to Greetings, folks. So in this video, I'm just going to introduce the idea of transforming graphs. And so what we already know is that we're already familiar with different types of graphs. So we know what the graph of x squared looks like, or what the graph of the square root of x, absolute value of x, and so on. And so those we could easily sketch pretty quickly. But what happens if I have some variation of that? So maybe the square root of x minus 3, or maybe I have 4x squared plus 7, or something like that. And so the idea here in these next couple videos is that if we see the equation, we should be able to take what we know about the parent function, we'll call them, and just kind of change them around a little bit. And so the idea here is that there's 4 different ways of transforming a graph. And we've seen this in geometry, and each one has a corresponding feature in the equation of that function. In the next couple of videos, we'll see how those parts of the equation play into the actual transformation. And so I just want to review transformations in this video here before we jump into that. And so there's 4 main types. There's shifts, which would just be sliding the shape around. So I'm not going to use an actual graph in this case. I'm just going to use this triangle here. And so a shift, well, you could just take it and without actually changing what it looks like, just move it around. We've seen graphs like that. So maybe you have a parabola over here and you have the exact same type of parabola, same shape, same curvature. It's just now scooched over here. What would the equation of that look like? And we'll talk about that. So you could shift an object horizontally, left, right, or you could shift it vertically, slide it up and down. Another type of transformation would be compression / stretches. And so that's literally taking the thing and stretching it or squishing it. And you could do that again horizontally, or you could do it vertically. So a horizontal stretch could look something like this, or a compression could look something like so. And likewise, you could do it vertically as well. The last one that we're going to talk about in the next couple of videos is reflections. Rotations actually can be quite spicy, and so we won't talk about those till later. And depending on the scheduling, we might not even get to it. But with reflections, again, that's just mirroring it. So we've seen examples of where a function could get reflected over a certain axis. So if it gets reflected over if this is my y-axis, if we get reflected over, then it just gets mirrored across that y-axis there. And so we could see that like so. An example of that would look like this. Or we could shift it or reflect it, over the x-axis, in which case it would go from, if this is my x-axis, it would go from the top down here, down there. And that would look something like so. Right? So, So in the next couple of videos, we're going to take a look at how these transformations visually then show up in the equation of the function. Alrighty, so catch you next video. In the next video, we're going to talk about shifting graphs.